Tesla's 2025 annual shareholder meeting has just wrapped up, and as many people predicted, the company's humanoid robot once again became the star of the entire event. For years, skeptics and critics repeated the same phrase whenever Elon Musk spoke about Tesla's robotics ambitions: "I'll believe it when I see it." But this time, Musk delivered the clearest answer yet. In front of thousands of shareholders and millions watching online, he unveiled the official, fully engineered Gen 3 version of the Tesla bot. A machine that not only looks radically different from its earlier prototypes, but also behaves in ways that clearly show Tesla has moved far beyond the stage of tech demos. This new generation is no longer a research experiment or a futuristic concept. It is now the foundation of a product entering a scale of production that almost no robotics company has ever attempted. Musk emphasized this by saying that what Tesla is building will be bigger than cell phones. Bigger than anything, he described a future where every person on Earth might want or eventually have their own humanoid assistant, comparing it to a real-life R2-D2 or C-3PO. He didn't simply predict big numbers. He spoke of annual production reaching 100 million units, and possibly even scaling to 1 billion per year. The crowd reacted with disbelief, excitement, and the realization that Tesla is no longer talking about robots as a side project. The company is openly describing a world-changing new industry they intend to dominate. As the presentation moved forward, the event's host welcomed everyone back to Tesla Car World, and the focus shifted to providing a deep dive into everything revealed about the Tesla bot: the updated design, the newly confirmed features, the production strategy, and the official launch timeline from Musk himself. All of these pieces finally came together in a way that painted a clear picture. This wasn't just an incremental update. It was Tesla's strongest statement yet that humanoid robotics will be the company's next transformative product line. Before diving into all the technical and design details, the presenters took a moment to acknowledge another historic announcement from the meeting. Elon Musk has officially become the world's first trillionaire. According to the compensation package approved by Tesla shareholders, this wasn't a typical salary or paycheck. In fact, it wasn't cash at all. The $1 trillion package refers to the potential long-term value of Tesla's stock options he will earn over the next decade. These options, which amount to 423.7 million additional shares, will vest only if Tesla accomplishes extremely ambitious milestones in AI, robotics, manufacturing, and autonomous systems. Musk clarified that the compensation package is not just a reward. It is a contractual commitment between him and Tesla's board. In simple terms, Tesla shareholders agreed that they want Musk to stay and continue leading the company through its next era, the era where Tesla becomes not just a car manufacturer, but a robotics and artificial intelligence powerhouse. This decision also serves as undeniable proof of Tesla's long-term commitment to the Tesla Bot program. For anyone who believed that Optimus might be a passing experiment, or a flashy prototype that might be discontinued if it didn't meet expectations, the $1 trillion vote essentially declares the opposite. Musk's compensation is directly tied to the success and expansion of Tesla's robotics division. That means Tesla's humanoid robot initiative is not only staying for the next decade, it is becoming one of the company's most important priorities. So what exactly does the Tesla bot, Gen 3, look like? And what can it do in the real world that previous generations could not? The most important revelation is that the robot no longer depends on external support systems. It doesn't need a human controller. It doesn't require a tether. It doesn't operate with hidden cables or remote signals. It is entirely wireless, fully autonomous, and capable of functioning with complete independence. Musk emphasized this during the event by repeating that there were no wires, no hidden assistants. What viewers saw on stage was authentic. 2 Optimus robots appeared during the presentation, and the moment they stepped onto the stage, it was clear Tesla had redesigned the entire exterior. The new 2-tone color scheme, a fusion of matte, metallic silver, and sleek jet black, makes the robot look far more refined than any earlier version. Instead of exposed joints and visible mechanical structures, the Gen 3 design hides virtually all internal components beneath smooth, continuous outer panels. The finish looks like a product meant for commercial and consumer environments, not just a lab prototype. The limbs have a natural motion, the proportions are more human-like, and the contours of the body show a level of industrial precision that signals this design is very close to production-ready. During the meeting, one of the most unforgettable moments came when Elon Musk stood up from his seat in the front row and walked toward one of the Optimus robots. Cameras zoomed in as Musk extended his hand, and the robot responded by gently reaching toward him. They held hands momentarily as Musk swayed in rhythm, prompting the robot to mirror his movement. This small interaction electrified the entire room. It was not a pre-programmed dance with pre-arranged steps. Instead, it was a real-time interaction demonstrating the robot's perception, balance, responsiveness, and its ability to understand human motion. For a moment, it felt like a science fiction scene unfolding in real life, and it showed how far Tesla's AI integration has developed. The bots also interacted with each other, performing a synchronized routine involving gestures, coordinated steps, and subtle communication. They weren't mechanically repeating instructions like old factory robots. Their movements had fluidity, even personality. They were perfectly balanced and moved with a confidence that suggested Tesla's breakthroughs in actuation and control. Systems were now maturing. Behind the scenes, Tesla has spent years building custom actuators. New electric motors, advanced joint assemblies, and a proprietary muscle-like system that gives the robot its strength and precision. Unlike most humanoids, which rely on either bulky hydraulics or slow servo motors, Optimus uses Tesla's custom-designed actuators that combine torque, efficiency, and compactness in a way that more closely mimics human anatomy. These actuators account for nearly every joint: shoulders, elbows, wrists, hips, knees, even fingers. Tesla's engineering team has repeatedly stated that the hardest part of building a humanoid robot isn't making it walk, it's making it walk safely, efficiently, and sustainably enough to operate all day without burning through its battery. The new design gives Optimus better efficiency, longer operating time, and cooler thermal behavior. Inside the torso, Tesla redesigned the battery placement and cooling architecture to distribute heat more evenly, helping the robot perform difficult tasks for extended periods. The internal computing hardware is also upgraded. Optimus Gen 3 uses Tesla's next-generation AI processors built in-house to run the same neural networks that power Tesla's full self-driving system. This means the robot sees the world using cameras, interprets its surroundings using neural networks, and makes decisions in real time, just like a Tesla vehicle. This shared AI ecosystem is part of what makes Tesla's approach different. Training a robot to understand the real world is one of the biggest challenges in robotics. But Tesla has an advantage no one else has. Millions of vehicles on the road collecting real-world video data every single day. The same vision system that identifies roads, obstacles, objects, humans, traffic patterns, and anomalies is now being adapted to help a humanoid robot understand kitchens, factories, offices, and daily living spaces. When Musk says Tesla is using the world's largest real-world AI training system, he is referring to this synergy. With each deployment of autopilot and full self-driving, Tesla indirectly trains its robot. As the meeting continued, Tesla presenters showed footage of the robot performing daily tasks, picking up boxes, sorting objects, folding clothing, assembling components, and balancing on one foot. It could kneel, lift items with careful finger control, and adjust its actions based on the material it touched. Every successful motion hinted at a larger vision, one in which the robot can perform nearly any job that relies on physical manipulation, repetitive motion, or basic mobility. Tesla also revealed updates to the robot's walking capability. The new foot design features improved grip, shock absorption, and pressure sensitivity. These changes help the robot maintain stability while stepping on uneven surfaces or adjusting to sudden shifts in weight. In the real world, where floors aren't perfectly flat, furniture moves, and unexpected obstacles appear. This type of adaptability is critical. As for its real-world applications, Tesla believes the robot will begin working inside Tesla factories first. The plan is to replace or assist with labor-intensive tasks, such as moving parts, loading materials, and transporting lightweight components between assembly stations. Over time, as Tesla Bot proves its safety and reliability, it will gradually be integrated into more complex workflows. But factory work is only the beginning. Musk has repeatedly said that the ultimate goal is for the robot to help people in their homes with cooking, cleaning, carrying objects, assisting the elderly, and providing personal assistance. With Gen 3's level of autonomy, Tesla is now much closer to that vision. At the shareholder meeting, Musk hinted at the official launch timetable,